Let us look at proposition number 13 of Works of Archimedes, specifically book 1 of On the Sphere and Cylinder. The proposition says the surface of any right cylinder, excluding the bases, is equal to a circle whose radius is a mean proportional between the side, that is a generator, of the cylinder and the diameter of its base. So let's see what we mean by that. Now, let's draw a line CD equal to the diameter of the base of the cylinder. Let's draw another line EF, which is equal to the height of cylinder. We find H such that CD is to H equal to H is to EF. That is mean proportion. H is a mean proportional between CD and EF. Now, what the proposition is saying is that if we draw a circle with the radius H, then the area of this circle would be equal to the lateral surface area of the cylinder. So we have drawn a circle of radius H. Now, let S be the lateral surface of the area of the cylinder. So what the proposition is saying is S is equal to area of the circle P. So as usual, we use proof by contradiction, saying that S is not equal to P or B is not equal to S, which means it has to be either less or greater. So case 1, assuming B is less than S. Remember, we can't directly measure the surface area of the cylinder. So we need to do something by which we can approximate the area of the lateral surface area of the cylinder. So what we do is we circumscribe a polygon about B and inscribe a polygon in B. And we do it in such a way that the ratio between the circumscribed polygon and the inscribed polygon is less than S is to P. Circumscribe a polygon about A similar to the polygon about B. So now build a prism on the polygon about A with the same height as that with the cylinder. So prism circumscribes the cylinder. Now let KD, we draw a line KD perpendicular to CD and equal to the perimeter of the polygon about A. So KD is equal to the perimeter of the polygon about A and it is perpendicular to CD. Again, we draw FL perpendicular to EF and equal to the perimeter of the polygon about A. So here FL is perpendicular to EF and is equal to the perimeter of the polygon about A. So that means FL is equal to DK. Now bisect CD at M. So MD becomes equal to the radius of the circle, because remember CD is the diameter of the base of the cylinder A. So triangle KDM is equal to polygon about A, because KD is equal to the perimeter of the polygon about A and DM is the radius. So triangle KDM, area of the triangle KDM is equal to area of the polygon about A. Parallelogram EL is equal to prism, surface of the prism. So here remember EF is the height of the cylinder and FL is the perimeter of the polygon. So which means the parallelogram EL. So let's complete that parallelogram. Now extend FE to N such that FE is equal to EN and join NL. So basically what have we done here? EL, the parallelogram EL is equal to surface of the prism. We want to work with a triangle whose area is equal to this parallelogram, because remember, this represents the surface of the prism. So we want a triangle whose area is equal to the surface of the prism. So what do? Remember, a triangle is half of a parallelogram. So if we are given a parallelogram and we want a triangle with an area equal to the parallelogram, we need to maintain the height and double the base, which is what we have done. So polygon about A is to polygon about B is in duplicate ratio of their radii. So polygon about A is to polygon about B is equal to MD square is to H square, because MD is the radius of the circle here. CD is the diameter of cylinder A, which means half of it will be radius. And polygon about B, that is H. So since they are in duplicate ratio of the radius of the circle on which they have been circumscribed, it would be MD square is to H square. Triangle KDM is to polygon about B is equal to MD square is to H square. Why? Because remember, polygon about A is equal to triangle KDM. So we are substituting it. So triangle KDM is to polygon about B is equal to MD square is to H square. Triangle KDM is to polygon about B is equal to MD square is to CD by EF. How did this come? Because H is the mean proportional between CD and EF. So that means H square is equal to CD times EF. Now, triangle KDM is to polygon about B is equal to MD is to NF. Now, suddenly, how did this NF come? Because think of it like this. We have MD is half of CD. So to maintain the proportionality, we have to arrive at something which is twice EF, which is nothing but NF. So triangle KDM is to polygon about B is equal to MD is to NF. Now triangle KDM is to polygon about B is equal to triangle KDM is to triangle NFL. Now here, remember, DK is equal to FL. The areas are in proportion. So that means triangle KDM is to polygon about B is equal to triangle KDM is to triangle NFL. Now here, polygon about B and triangle NFL, they are both having the same ratio with the same object, that is triangle KDM. So that means they are equal to each other. So polygon about B is equal to triangle NFL. Since triangle NFL is equal to parallelogram EL, which is equal to surface of prism, that means triangle NFL is equal to surface of prism about A. But the polygon about B is to polygon in B is less than S is to B. So that means surface of prism about A is to polygon in B is less than S is to B. Or alternately, we can say surface of prism about A is to S is less than polygon in B is to B. Now, polygon in B is to B, when we say whatever the property these two have, the same will apply to this. So, which means prism about A is less than S, because polygon in B's area is less than the area of B. But we know that a circumscribed prism about A, cylinder A, will be greater than the lateral surface of the cylinder. So we have reached a contradiction, or we can say which is impossible. Therefore, B is not less than S. Similarly, we have to prove for the case where B is assumed to be greater than S. So let's do that now. So in the second case, we assume that B is greater than S, and we circumscribe a polygon about B and inscribe a polygon in B such that the ratio between them is less than B is to S. Now, inscribe a polygon in A which is similar to the inscribed polygon in B. So it is already inscribed. Build a polygonal prism on the polygon in A with the same height as that of the cylinder. Draw KD perpendicular to CD and FL perpendicular to EF, where both are equal to the perimeter of the inscribed polygon in A. In the previous case, it was a perimeter of the circumscribed polygon in A. Here it is inscribed polygon perimeter. Bisect CD at M and join MK. Extend FE to N so that EF equal to FM and join NL. Triangle KDM is going to be greater than the polygon in A. Remember, MD is a radius of the base of the cylinder and KD is the height of the cylinder. But here we are talking of the inscribed prism, and here the perpendicular from the center to the side of the polygon is less than the radius of it. So that's why triangle KTM will be greater than the polygon in A. Now, triangle NFL is equal to parallelogram EL. Remember, EL is the surface of the prism. We wanted a triangle which will have the same area. So we kept the height same and we doubled the base. Now polygons in A and B are in duplicate ratio of the radii of A and B. So polygon in A is to polygon in B is equal to MD square is to H square, where MD is the radius of the base of the cylinder, or in other words, the polygon in A, and H is the radius of the polygon in B. So polygon in A is to polygon in B equal to MD square is to CD times EF. Again, H is the mean proportional between CD and EF. So that means H square is equal to CD times EF. Polygon in A is to polygon in B is equal to MD is to NF. Again, remember, we had CD times EF. Now, CD is twice MD. We are given FE. We want twice of FE. So that is why we extended it so that FE equal to EN, which is NF. So MD is to NF. So polygon in A is to polygon in B is equal to triangle KDM is to triangle NFL. Because KD is equal to FL. So triangle NFL is greater than polygon in B. Why? Because triangle KDM is greater than polygon in A. Triangle KDM is greater than polygon in A, which is impossible. Why? Because polygon about B is to polygon in B is less than B is to S, which is in turn less than polygon about B is to S. So polygon about B is to polygon in B is less than polygon about B is to S. So which means polygon in B is greater than S, which is greater than the inscribed prism. Remember, see here, polygon about B, polygon about B. So the numerators of these two ratios are same. So for this proportionality to be less than, polygon in B, that is the denominator, has to be greater than the other denominator. So polygon in B is greater than S, which is in turn greater than inscribed prism. That means polygon in B is greater than surface of the prism, which is a contradiction. Why? Because here we said surface of prism is greater than polygon in B, and here we are saying polygon in B is greater than surface of the prism. So that's why it can't be greater as well. B cannot be greater than S. So the only option left is to say that S is equal to B. So we have proved that the curved surface area, or what I have been calling lateral surface area of the cylinder, is equal to the area of a circle whose radius is the mean proportional between the height of the cylinder and the diameter of the cylinder. So that is proposition number 13 of works of Archimedes, specifically book 1 of on the sphere and cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.